So if you remember our data from yesterday, this is our apple data. I put it on a dot plot for you. Our lowest data point was 4.1 and our highest was 6.5 or 6, I can't remember. But anyway, I drew a little box plot to show, remember our median was 6 and our lower quartile was 5.7 and our upper quartile was 6.2, which made our interquartile range 0.5. And so basically we're trying to figure out if any of my apples are outliers, if any of them are really, really small compared to the rest of them, if any of them are really, really big. And this actually surprised me. I didn't realize that apples were so uniform. I think we've kind of gotten this in commercialism, you know, I could go into a whole talk on that, but basically, you know, they basically try to grow these apples to be about the same size because people like a certain size, right? And it's very uniform. I mean, they really were not very different at all. But I had this one little tiny apple, so let's find out if that apple is an outlier. So again, we take our interquartile range and we multiply it by 1.5. So we do 1.5 times our IQR, which is 1.5 times 0.5, and that equals 0.75, excuse me. So what I'm telling you is that if I go this way, 0.75, then anything below it is an outlier. And if I go this way, 0.75 from the upper quartile, then anything above it is an outlier. So let's decide if we have any outliers. So what is it? What is 0.75 away from 5.7? So that would actually be 4.95. So right there would be considered an outlier, or 6.95. Okay, so anything above 6.95 ounces would be considered an outlier, and anything below 5.95 ounces would be considered an outlier. So do we have any outliers? We don't have any on the top, but we do have this one on the bottom. That little tiny apple is an outlier because it's so far away from the distribution of the rest of the data.